Welcome everyone. Can you hear me? Because like I cannot hear myself, so it feels like I'm without microphone in here.
No, you're good.
I'm good. Yeah. People in the back. Yep. Okay. So again, welcome everyone. My name is Michał Budzyński, as you could hear before, or how your Greek printers tried to convince me today on my ID, Micha Budzy ? Let me introduce myself first. So, for last like 11, 12 years, I worked in a whole bunch of different companies as a JavaScript guy, starting from a junior developer and at Gadu Gadu, that's this yellow and red sun. It was like the biggest instant messenger in Europe back then. Then I worked at Mozilla in Paris as a boot-to-gecko developer. I left Paris a couple of years ago and started working at Walmart. But still as a developer. Then I switched to GTech. That's like if you visit casinos or play like Lotto or any other national lottery, I was probably paid from your money. And now I work in Sochi. Sochi is a San Diego-based startup. We do like social management tools, the best social management tools that are there. And yeah, so I also watch a lot of TV shows. Actually, I'm just like working, eating, sleeping sometimes, and watching TV shows. And I have a GitHub repository where I track it, because like if you watch so many TV shows, it happens time to time that you will try to download, to buy legally the same episodes you already watched. So I made this screenshot 2 days ago, and it shows that I watched 5,928 episodes. What's around 3,358 minutes, was like 140 days. And I have a request. Let's say so. I have this. I have this GitHub repo in here. That's my list of TV shows I watch. Yeah, and in here there is a list also. You probably cannot see that, and I probably cannot make it any bigger. I do. And this is the list, shows to consider. And people, like myself, but people are, so as I said, this is the GitHub repository. So people are forking it and sending me pull requests with TV shows they think I should watch. And then like they can vote for shows that are here still. Sounds stupid, but I already have like 27 contributors. And my GitHub streak looks like this because of this. So, where's my streak? Oh my God. No, I did not. Where's the number? Where's the GitHub guy? Okay, whatever. Yeah, so please, if you know some TV show I didn't watch yet, send me a pull request. If it's already on the list, just put your vote there. Okay, let's start about pixels. So since the very beginning, I started like doing computer stuff before my primary school, probably. I don't even remember when. And I was amazed by this art of showing things in such a simple way that there are actually like 3 dots, one over another, and we all knew what TV show it is. We do? Really? Yeah, Simpsons, of course. Because back then, games looked more or less like this. I mean, I know that games looked like this like 20 years before I was born in US, but Poland was on the other side of Iron Curtain. So that's how it looked like back then. When our displays had like 30, 420 pixels, and everything that was meaningful was just a pixel. Like this paddle is like 4 pixels wide. Ball is just a pixel. And it inspires your imagination, so you could actually feel like playing Pong or whatever Pong is, table tennis, right? Or something like this. And of course, it happens when the new technology shows in. The people that are working in this technology are reinventing the wheel, so trying to implement the same things that people already did like 50 years ago, but in this technology. So JavaScript and all the web didn't have any pixel manipulation possibility at all. But we wanted it so hard that we fake it. So back in the days when there was something called DHTML, and D in here stands for dynamic. And you knew it's DHTML because when you tried to run your DHTML code in IE5, you had this warning there that, are you sure you know what you're doing? Because it can destroy like whatever you have there. So back then, I wrote my first Snake game. Everyone knows Snake game. Everyone, like most of you probably had this Nokia phones and play it. Using a table. So that's like, this is not the actual implementation I did back then, but this is the game written by one of the guys I'm mentoring. So it kind of works. Yeah, whatever. So as I said, this is just a huge table, and all the cells are pixels, and if the pixel is active, it just have the active class. And like the fruit has different like fruit class. So we had the, whoops. So we could write pixel games in the browser, but it was kind of, it was cheating. It wasn't what we really wanted. And afterwards, there was this company called Apple. Probably some of you heard of it. And they have this operating system, whatever it's called now, like with this fancy, whatever. Yeah, they have two operating systems, you're right. And they introduced widgets in their macOS in 2005. And those were actually web-based widgets, but you cannot do things like this, I don't know, chart in here, or probably just this one, yeah, in pure HTML. So they proposed a new HTML element with all the API, and they called it Canvas back in 2005. And the idea was so fresh and new that the other browser, that's not on purpose. I didn't crop Internet Explorer on purpose, really. It's the resolution. So the idea was so fresh and nice and gives so many possibilities that after it was implemented in WebKit, like Chrome had it out of the box because it's WebKit based, Firefox implemented it in Gecko, Opera implemented it in whatever they had back then. So it was available in all over the web in all the browsers. And from my point of view, the best thing that Canvas gave us is the ability to manipulate single pixel. So there is this method called getImageData, whatever, I don't know what's the proper pronunciation. Data or data? Okay. So when you call it on the canvas, you'll have this object that has a width and height of the part of the image the data was requested from, and an array of numbers. So they use getImageData use 4 numbers to describe 1 pixel. And first number is, of course, color red. This is green. This is blue. And this is opacity. So we can see that the first pixel in here is a white and visible pixel. And then the next pixel starts, etc. So why is it so important? Why was it so important? Why we wanted this feature so much in the browser? So what are like real life examples that, what are the real life examples where we can use those? For instance, if you have a lot of free time and want to implement Photoshop on Canvas, now you can do that. I mean, you could not do that before because there was no Canvas, but you get the idea. So there are photo filters, for instance. And now I will do some live coding. And this shit never works on conferences. So just please don't laugh. And I need to find my live coding thingy first. It's in here. It's in here, yeah. Can you see anything in here? Okay, so that's not those are my slides. This is not this, and this will be the example. So let's open it in the browser first. I have it in here. Yeah. So as you can see, there's nothing. And now, with a little magic, I even wrote my own jQuery in here that covers 90% of the jQuery usage. What we want to do in here is first take a canvas using our awesome jQuery, because canvas is already here, as you can see. Now, we need a context of the canvas. And so far, 2 of them are supported, so like 2D and 3D. That was easy. And now, like, give some dimensions. Okay. And now, let's create an image. Crap. And we set the source of the image to image. And when the image will be loaded, we get the context of the canvas and draw it. In position 0, 0, so at the beginning of the. And we can see a beautiful Thessaloniki photo. And now let's apply some filters. Remember this part when I said that live coding never works? It will happen now. So we get the pixels from the image. And now, in the loop, yeah. Okay, we need to set exact chords. And now, now we will calculate the average. I know that okay, I don't want any more Crockford emails on you shouldn't do JavaScript like this on conferences. So let's do it like this. So we get the first pixel plus the second pixel and plus the third pixel. And divided by 3. So that it will give us the average value of those red, green, and blue data. Red, blue, and green data. Red, green, and blue data, yeah. And now we just put those data back. So yep. So we set each pixel's data to be the default, and after this loop, we put it back to the image. And nothing happens because live coding never works. Missing colon. Of course. Why you didn't laugh when I did that? Oh, because it's not here. I missed the statement. Yeah. And now we have almost white. Okay, let's imagine it's all black and white, right? Because we applied the proper filter there. And live coding never works. What else? Face detection. Because we can do now all the math that was possible in all the graphic software just inside our browsers. So there are like plenty of algorithms where you could detect things on images. And like the most popular is detecting a face. So it's possible with the Get User Media web API, you can grab the stream directly from your camera and draw it on a canvas, and then do whatever pixel manipulation you want on this canvas. So yeah, so I hope internet works. It does. Okay, so I need to remove my anti-FBI sticker first. Yeah. So it detects the face. Can you see it? Yeah. It detects the face, and you can do whatever, umbrella, Ella, or remember, your vote can change the world. Whoop. Yeah. Let's back to the slides. So that's one of the things you could do with manipulating pixels. And also, as I said, like those algorithms, there are algorithms that detect things on images. So those are not only faces, but this example is like the easiest because most people, most like business, it has most business value. But there is this library called Kittydar, where you can detect the face of a cat on the photo. And so a couple of years ago, we had this crazy idea with my friend who had a cat back then to write a game. Because if you can detect an object on the image or on the stream, you can track its movement. So we wrote a first-person shooter controlled with your cat's head. So you just took your cat like this, start your webcam, and play the game with a cat. Yeah, it didn't really work because, as you could see, the algorithm is quite slow. It took like a second, almost a second, to detect the cat's face on the photo, and the cat's kind of not with us anymore. So this project was never finished. But it's possible. Now, in the browser. What else? There is this thing called steganography, and it's actually like native to you guys. I mean, it was created in ancient Greece. And the idea, it's an art of hiding messages, of sending, it's like cryptography, but the main difference is that in cryptography, you know that the message is there, but you cannot read it, so you need to somehow decode it. And in steganography, you don't even know that the message is there. So back then in ancient Greece, there were like people tattooing messages on the slaves' scalps and send them to another cities where they shaved their heads and the message was there, or put the message on the wooden table behind the wax table that the fake message was on, and things like that. So how we can do that with Canvas and JavaScript inside our browser. So as I said at the beginning, and then like 3 times afterwards, each pixel has like 4 numbers that represent it. It's red, green, and blue colors, and the opacity, the alpha channel. When we write those numbers in binary, it will look like this. I hope everyone understands the idea of binary, so I don't need to explain how this works. So the least important bit in all the in each color is the last one. So in here, this bolded 1 at the end. And we can also, we need 8 bits to write one character. So like A looks like this, and B looks like this, etc. So compiling those two pieces of knowledge together, we can write one letter on 3 pixels, because when we change the least pixels in each color in here, it's like that's how A looks like. So we can see it's 0, 1, then 5 zeros and 1. So it's like here, 0, 1, then 4 zeros, and 1 at the end. So for the human eye, when you will look at the image with those changes, there's no difference at all. Like, I mean, maybe for me, I have glasses and I barely see anything, etc. But yeah, and you don't only can code a message like a text in the image, but all kind of data. So for instance, that's like the Wikipedia example. That's the cat's image that is coded, that is steganographied, hidden inside this image of the tree. It has poor resolution, but it's there. Okay, so how about Node? Like Node.js is kind of huge in the community now, like for the last couple of years, and we all know that Node runs without the browser. So where's Canvas there? And how can we use that? So I wrote this small library called ASCII images, and I'll show you how it works, I hope. Yeah. So we're in Node. Can you see anything? Probably not. Whoop. Okay. Is it any better? Okay. How to change the color? Okay, I'm too dumb. Can you see anything in here? Okay. So we ASCII images, so we require ASCII images there. Okay, I need to do it like this. I forgot, sorry. But I will just say what I'm doing. I put the test PNG as a first argument because that's the URL to the image, and then in the callback with the data, I just... Oh, I thought I broke something. Don't do these things without further processing, please. We console log the output of this, and yay! So it's the DEVit logo, but in ASCII, and displayed. Each pixel is displayed as a separate color space. I tried to make it like a default canvas renderer for Node, so you could actually write game and run it using this, but it was even worse than controlling your game with your cat. I mean slower. Okay, so as I said, with those features, with Canvas, with access to all the pixels and ability to change them however we want, we can do everything. Yeah. Thank you. That will be all. Can we turn like the main light on? Because I'll die in 30 seconds. Are there any questions? There are no questions. Great, really. Why are you doing this to me? Okay.
Hello? Okay. Why have you not watched Archer yet? Archer, the series, like the show.
Because there's too many episodes, and I did the first season, it's like
Okay.
7 or 8.
Yes.
It's, but I cannot watch it now because the main character's voice is the voice of the father of Rick,
Bob's Burgers.
in Rick and Morty.
No, that's the accountant. But
Okay,
he is,
one of
yes.
the main guys.
Right.
So it's very hard for me because I'm just after the 3rd season. I'm crying that Rick and Morty we will need to wait for like next year
Yeah,
for
I know.
it. So I cannot do that to my favorite show.
Okay. All right.
You have one more
everybody,
contributor for today.
Everybody, go make a pull request and vote for Archer on his repo. Okay. I trust you guys. Right. That was it.
Any other pixel-related question?
Actually, no, I'm not a game developer, so sorry.
Okay. Thank you. Yep.
Any other question?
No.
Ah, there. And just hold on.
Okay, I cannot hear you. I'm almost deaf, so. No, I have people I pay for doing it. Yeah, it works better when you turn it on.
Is there any place where we can find any algorithms for the canvas manipulation you did in the example? You did a grayscale, face detection, all this?
So, yes, you can just Google face detection JavaScript. And you have like plenty of examples, and some
Okay.
of them are awesome, some of them are shit, but there is like shit ton of it. And like same thing with, probably the cat's face detection was just implemented by this one guy because
It was nice.
other people have works and families, but yeah. So I have most of those examples. Maybe not most, but the ones that I implemented on my own, like steganography or this ASCII pixel thingy. It's all on my GitHub. And please follow me on GitHub. I'm doing a lot of fun things over there, etc. Yeah. Are we good?
Thank you so much.
See like a couple of the people. Okay.